How can we solve renewable energy storage costs? Imagine a world where clean energy flows smoothly, day and night, rain or shine. That's the goal of making renewable energy more reliable and affordable. But storing energy from sources like solar and wind is still expensive. So, how can we bring those costs down? Let's explore the facts. Right now, the main challenge is that renewable sources don't produce power constantly. Solar panels generate energy during the day, and wind turbines depend on wind speed. To keep the lights on when the sun isn't shining or the wind isn't blowing, we need good storage options. These systems hold excess energy when supply is high and releases it when demand is high. Without efficient storage, renewable energy can't fully replace fossil fuels. One way to cut costs is improving battery technology. Lithium-ion batteries are the most common now, used in everything from phones to electric cars. They store energy in small, lightweight units. If we can lower the cost per kilowatt-hour of these batteries, electricity becomes cheaper overall. For example, if battery costs drop to about $1 per kilowatt-hour, it could cut energy costs by up to 3 times compared to current costs of around $1,000 per kilowatt-hour. This would make renewable energy much more affordable. Besides batteries, other storage methods are available. Pumped hydropower uses water stored in reservoirs at different heights. When energy is needed, water flows downhill through turbines to generate electricity. This method has been around for a long time and can store energy for up to 2 days. Compressed air energy storage works by compressing air into underground caverns when there is excess power. When needed, the compressed air is released to spin turbines. Both are cost-effective for large-scale, long-term storage. Thermal energy storage is another option. It involves storing heat in materials like molten salt or sand. This stored heat can then be used to produce electricity later. It's especially useful for industrial processes or solar power plants. Capturing and reusing excess heat reduces waste and lowers costs. Energy storage also helps manage peak demand. During busy times, stored energy can be used instead of running expensive, polluting backup plants. This process, called peak shaving, saves money and reduces pollution. Load shifting involves storing energy during low-demand times and using it during high-demand periods, making the grid more efficient. Policies and incentives are key to speeding up storage development. Governments can offer tax credits, rebates, or grants to encourage investments in new storage projects. These incentives help lower the initial costs and motivate companies to innovate. They also support integrating more renewable energy into the grid, making it more stable and reliable. In summary, solving the high costs of renewable energy storage involves improving battery and other storage technologies, using storage to optimize grid use, and applying supportive policies. By doing so, we can make clean energy more affordable, reliable, and ready to power our future.